Hi, Mac. Hi, Mac. Hi, Mac.
It's just me and you, Mr. Professor.
Just for right now, yeah, that's it. So we'll have to see.
No,
how
no
it
one
goes
else
on.
is gonna come. It's just gonna be me and you all the time.
Oh, you think so?
No, I'm kidding.
All
All right.
right. Let's hope that we have you. Were you able to load that up yet?
Which
Mac,
one?
The
I'm not home. I'm at work.
Oh, okay.
Right
No
now.
problem. So I let it go.
I'll send it to you if I yeah, till tomorrow at 8:30.
I think I opened it until tomorrow. I can actually go in and look.
Thank you so much. I appreciate it.
All right.
Thank you.
Anybody
All right.
else? Oh, that must have been from you. Okay. Kara's here. Okay, you're seeing what I'm seeing, aren't you, Mac? Drop boxes.
Yeah.
And we're
Yeah.
talking about the calorimetry Dropbox, right?
Yes, sir.
Okay. Edit folder. Okay. Restrictions. Hi, Kara. How you doing?
I'm all right.
Not all right?
I'm all right.
Okay. All right. Mac, I'll give you till noon tomorrow. Okay?
Thank you. Yes, thank you.
Ah, crap. Brian's in here. Oh, there it is. Okay, so you've got until noon tomorrow, right? Mac? Mac?
Yes, sir. Thank you. Yeah.
Are you seeing the screen?
Yes, sir.
And you're seeing it down here. It says it ends tomorrow. Whoa.
Yep. Thank you.
No. Today is the 31st. I almost did an April Fool's joke on you.
Oh no! Don't do me like that.
Yeah. Oh, wait. Today is Wednesday, so it has to be the first. Yes. So you see,
Yeah,
yes,
tomorrow.
it is April 1st, 12 o'clock. It was almost another April Fool's joke. So how we doing, ladies and gentlemen? Okay? Okay? No? Kara's
Yeah.
okay. Brian, you doing all right?
Yeah.
Yeah. Okay. That's as good as I'm going to get, I guess.
Yeah.
Okay, guys, I'm going to play you something tonight that is going to be the absolute saving grace for you. I'm hoping to get a couple more people in here before I start it. All right, we're in. Right now, I'm in the course content. I am in the spectrophotometric determination of a dye. Okay? You see this down here, this link. I'm going to get back to there. 1 second. This is driving me crazy. Now, where is it at? Thank you. All right. Stop. Stop. Thank you. All right. So what am I doing? All right. I'm going to get into my courses again. just to show you where it's at. Come on. Thank you. This is going to be a godsend, guys. All right, so course content, spectrophotometric determination of a food dye. You're going to go down. Third thing down there, the third icon down. How to plot a graph in Excel and find the slope of your line of best fit. Guys, if you learn to do this, you're never going to have to do a hand-drawn graph again. It is super, super easy. Okay? So I'm going to go ahead and share screen. Where did it go? Tell me if you cannot hear this. It's worth 8.5 minutes of your
Okay,
life.
so this video is about how to use
Can you hear
Microsoft
this?
Excel to create a graph. So in the food dye experiment, you'll be asked to
Yeah, we can hear it.
make some solutions where you're going to find the absorbance of them. So what I have here is Excel. I open up Excel, and what I made in this column, the A column, I'm calling it the X data. I'm calling the B column the Y data. In your case, your X data is going to be the molarity or concentration of your food dye samples, and B will be absorbance. That's why I label them this way, but generally speaking, you have X data in the A column, Y data will be in the B column. And I made up some numbers. So again, this is not what you're plotting, but I just made up some numbers just for illustrative purposes. What I'm going to do, I'm going to highlight, I click, in this case, on the 10. I'm going to use my left mouse button, hold it down, go to your right, and then go down until you highlight all those cells. Now in Excel, you want to make something called an XY scatter plot. So an insert, at least in my version of Excel, an insert, there's a menu here where it says charts. And if you click if there's a one here with multiple scatter, there we are. So it says insert XY or bubble chart. Click the down arrow and select XY scatter. So in my version of Excel, you can see what happens. As soon as I highlight it, click OK, and then it makes the graph for me. So these are all the data points that correspond to X data and Y data. If you move the cursor over one of them, you'll notice it says 30, 85. Well, that's this point right here, 30, 85. X is 30, Y is 85. So when you do this, you should have, for example, you might do 0, 0 for your blank. You might do your different molarities you calculated for your Lua red. And this will be your Y, then will be the absorbance you get from the spectrometer. Now what you want to do, you want to add something called a trend line. So basically what I'm going to do, I'm going to highlight over I'm going to hover over one of these points. I'm going to right click, and on my version of Excel it says trend line. Left click. On the right hand side, now you have some choices. You do exponential, linear, logarithmic, polynomial, power, moving average. And by default, mine's selected linear. So I'm going to leave that selected that way. And now if I look at my options, it says forwards and backwards, you can leave those alone. We're not doing any forecasting. Set intercept, I'm going to leave that alone as well too. You do have the option to set the intercept to 0. That is something you could do if you wish. I'm not going to, and I usually don't. Display equation on chart, that one you definitely want to check. And one below it, display R-squared value on chart. That's up to you. The R-squared value will tell you how linear your data is. I'm going to select it. You don't need to do this.
Sorry.
And basically what happens if you do that, if it's completely linear, completely correlated, you're going to get a 1.0 for this R-squared value. The more linear it is, the closer to 1 it's going to be. In this case, I get 0.9929. That's pretty good. You can move it around. Basically move your cursor over it when it looks like a multiple arrowhead. You can left click. You can drag it to wherever you wish. Okay. That's how you make our chart, and that's how we get the trend line. So when you need your line of best fit, my equation, I got y equals 2.96x minus 1.8. So you're going to get an equation like this when you graph, when you find the line of best fit from your food dye. Now, we need to make the chart a little bit more pretty. So if I click on top here, if I click on the title, I can modify the title. So in my case, it may be, if you make, usually it's, y versus x is a reasonable title. You don't want to call it just chart 1. The title should convey enough information so I know what's being plotted. So maybe if this is your experiment, you might do maybe absorbance versus molarity of Allure Red, or something like that. Now, you also need to give it some axes. Give it axes labels. So in my version of Excel, you have an option called Add Chart Element. So if I highlight here, and if I left click, I have axes, axes titles, chart title, chart data labels, among other items here.
Guys, do you see
So
where
I'm going to
do
add,
you see where my cursor is?
under axes titles, I'm going to select primary horizontal. Something like this. Something like this. And I see it's
It's not, just 1 second. Did you see those things that were up over here?
Yes.
In my version, all I have to do is go to the top one, click on that, and that will set my axes titles and labels, okay? Sorry, I just wanted to point that out.
covering up my numbers. So maybe I wanted a different option for that. Let me see. Okay, so it seems I want to keep it there. So if I make my chart, I can click on my chart. I can grab the window here. If I click on the chart, I can make this a little bit smaller, and now I can make it fit. Okay, so if you click, if your axis title happens to cover up the numbers, if you were to click on the main window of the chart here, you should see these chart lit up. If you hit the corner here, you can drag it smaller. You make it so it doesn't cover up the numbers. Now you can click on chart title. You can double click on it, and now you can change the title. So this will be whatever your x-axis actually is. So in your case, it's actually going to be the molarity of your solutions. You can just call it molarity, maybe parentheses m, indicate the units, and close parentheses.
Both of those are
Now we need to do the same
required.
thing for the y-axis. So add chart element, chart title, primary, vertical, and there we go. And I see we have the same kind of problem. It's barely fitting on here. If you want to make it a little bit smaller, you can. See what that does. There it goes. So you make it fit a little better if you have to, if it doesn't already fit nicely. And now you want to change that. I'm hitting the backspace just to delete this. And I'm going to call this maybe absorbance.
Absorbance has
Again,
no
whatever your
units.
y-axis is, you can call it that. And there you can click off the side, and there we go. That gives us our graph. And then we have proper labels. If you want to make it a little bit prettier, you can go ahead and change. You can change some of the different layouts. You can change colors. You can do all kinds of different things as well. Another option, if you would right-click on it, if you right-click on here, you can change its location. So it says Move Chart. So I'm right-clicking on a white space over here. Click Move Chart. Now you can change it into New Sheet. If I do that, that creates now a new tab at the bottom of my screen called Chart 1, and there we are. And again, from here we can play with the sizing and so on to make it fit as best as possible. You can do that. We can change the font if you need to. You can drag this down. You can change the font size if you want to as well. You can play with this however you want. But anyways, this kind of gives you a basic idea to get what you need, especially how to handle this equation, the line that best fit. If you want to make that a little bit larger, you click on it. Let's see if I can enlarge the size. Oh, here we are. If you double click on the text box, double click on it, I can now change the size to make it, something, whatever I want. There you are. So you can play with that. You can play with the axes that way. double click on the box, and there's options then to change the different sizes and so on. But what's most important, can you get the graph made? Can you get it set for linear? And can you get this equation set properly? That's what you ultimately need to be able to do. You will be asked to upload a picture of your chart. So once you've gotten to this point, take your phone or screen capture of some sort, get a picture of it, and then you can upload it with your report.
Okay. All right, I'm going to stop share. Okay, are we good with that, ladies and gentlemen? Again, I don't need this. Crap. Okay, we're going to get out of here. Going to get out of here. All right, again, where you find it, course content. Third icon down. Third icon down, how to plot a graph in Excel. You don't have to do this. If you really want to hand draw it, God bless you. The other thing I found that Excel does not do a good job using scientific notation. So you may want to put in the period and all the zeros for the concentration. Because if the concentration is not correct, then your slope will not be correct. Make sure when you're looking down at the x-axis that you are seeing numbers that reflect what they should be. Any questions on this? Anything from anybody? Okay.
Do we upload it along with the journal, or don't you want to upload it?
No, you're going, Brian, I believe, if I am not mistaken, part of your report has one question that you have to upload the graph for.
Okay.
All right. Now, graphs, they need a title. Write these down. You need a title. Each axis needs to be labeled. In your case, it's going to be absorbance versus concentration. Where the axis has where the units of the axis has a label, put that in there. In the case of absorbance, there is no unit, so leave it blank. In the case of concentration, you're going to want to put either a big M or moles per liter, something like that. Another thing each graph has to have is you have to have a scale. In other words, each box that is in your graph has to be worth a certain amount of value. And that number cannot change from one box to the next. So the scale has to be good in both the X and Y direction. If you do it by Excel, it will be. And the other thing is your graph has to cover 70% of the surface. Don't worry about it with Excel. Any questions on the graphing itself? Okay, now we're going to go ahead.
What was the first point that we have to make sure?
Title.
Okay.
And as Dr. Warden said, the title can be something as simple as y-axis versus x-axis, absorbance versus concentration. Simple enough, guys.
Okay.
Anything else, ladies and gentlemen? Okay, I'm going to stop share. And I am going to go to, everybody's seeing the Beers Law PowerPoint. Everybody seeing this?
Yeah, I see it.
Yes.
Okay.
Yeah.
All right, now, the equation, Beers Law, is actually the equation you see in front of you. A, the absorbance of your substance, is going to be equal to this funny looking E, which is actually a Greek epsilon, times B times A. Sometimes you will see this as absorbance is equal to ABC. So we're going to need to figure out what these things are all used for. If you have two different t-shirts, one's royal blue and one's sky blue, are the dyes absorbing light at the same rate? Are the colors the same? Come
No.
on,
No.
Kara, come on.
I mean, they are both blue. They're just not the same shade.
That's an answer I'd expect out of a male.
Well, unfortunately, I was not raised to care about color, so I see it that way.
All right. I have been asked, ladies and gentlemen, when I work for Macy's, I have been asked to, brides will bring in a swatch of a bridesmaid's dress and they will say, do you have 7 ties that are exactly this color? And I then have to proceed to tear up my tie table to try and find one so I can order 7 of that exact variety. In any case, both of these are absorbing color. One's doing a much more effective job than the other. And because it's doing a much more effective job, it's absorbing more of the light. So, depending upon what compound you're dealing with, it will absorb light to different degrees. Would you all buy that? So this is where my epsilon factor comes in. Each individual substance will absorb light to different rates. Each substance has a molar absorptivity or epsilon value. Now, if I take my vial and I double the concentration, now as my light is passing through my first vial, it's only seeing maybe 2 molecules. Again, this is an exaggerated situation. All right, I double the concentration, and when that light goes through again, it's seeing 4 molecules. Which one do you think will absorb more of the light?
The one that has been double.
The one that is more concentrated. So if my sample is more concentrated, I get more absorption. So again, my absorption is directly related to my concentration. Again, does this make sense?
Yes.
All right. Now, if my path length doubles, am I also not going to see twice as many molecules? If I have the same concentration, these 2 cells have the same concentration. This one happens to be twice as wide. As the light goes through it, isn't it also going to see twice as many molecules?
I would think so.
So again, I have a direct relationship between my absorption and my cell length. But I can fix that one. If I just say, okay, every cell I put into my instrument is going to be 1 centimeter long. If each cell is 1 centimeter long, it goes away from my expression. And I get my absorbance is going to be equal to my molar absorptivity times my concentration. What happens if I have nothing in there? If my concentration is 0, what's my
You-
absorbance going to be?
0.
So I have 0 absorbance and I have 0 concentration. So if I'm plotting this as a line, my y-intercept is 0. So if I'm looking at this, does this formula, if I find this formula, A is equal to epsilon C plus 0. Does that look like something that you've seen in algebra? Maybe on a Cartesian plane?
Yeah, kind of.
Well, what's it look like? What is this? What's this the equation of? Maybe I could make it a little easier for you. What if I would just call this y is equal to mx plus b? Does that shake any memories for you?
Yes.
What is that, Brian?
Is it the y-intercept or the slope?
What's the whole thing? What is this y equals mx plus b? What's that the equation of?
Point slope intercept.
What's it the equation of, guys?
A line.
Thank you so much. It's like pulling teeth tonight, guys. So, if this is the equation of the line, and we substitute E for M and C for X and A for Y, if we plot the absorbance versus the concentration, isn't M going to be equal to my molar absorptivity? Come on, do I hear an amen somewhere?
Yes.
If I plot absorbance versus concentration, I will get a straight line. The straight line that I get will have a slope, and that slope will be equal to the molar absorptivity of my dye. So we are going to make a plot. The whole basis for the first half of this laboratory, we're going to make 3 or 4 different solutions. I've forgotten which. And we are going to take like 1 milliliter of the dye solution, put it into 100 milliliters of solution. Then we're going to take 5 milliliters of the dye, put it into 100 milliliters, 10 milliliters into 100, 20 milliliters into 100. So in effect, I have accurately measured 4 different concentrations of my dye. Then I am going to take each one of those 4 solutions and I am going to put that into an ultraviolet spectrophotometer, which is designed to measure the absorbance. So I'm going to have my concentration that I'm going to plot against my absorbance. And I am going to get a straight line from that. I'm going to analyze it for my equation of the line. And I am going to come up with a slope. The slope is going to be equal to my molar absorptivity. Do I have anybody confused yet? Are we all good with this?
Yes.
Yeah.
All right, now what is going to happen? We have made our graph. The whole reason for the graph is just to get the slope, which is our molar absorptivity. All right. If I put just straight Gatorade into the UV, I'm going to fritz it out. It's going to be so high in absorbance that I'm not going to be able to read it. So what I have to do is I have to dilute out my Gatorade so that I get a reasonable absorbance. Okay? I've got a dilute Gatorade sample that I am now going to put into my ultraviolet. And I am going to get an absorbance. Remember, my absorbance is equal to my molar absorptivity, which is the slope of the line of my graph, times my concentration. So my absorption divided by my slope will give me the concentration. All right. Are we good there? Do we basically understand how we're going to do this particular experiment? Okay, first part, we're just doing our dilutions and obtaining the absorptions. To get the concentration of the different samples, we're going to have to use the equation M1V1 equals M2V2. You will be given a stock solution of the dye. And you are going to take a certain amount out of that stock solution and you are going to put it into a volumetric flask. A volumetric flask, that's the funny looking one that has that big bowl on the bottom and the very skinny neck. A volumetric flask is designed to read one volume very, very accurately. So you take your 1 milliliter from your stock solution, put it into your volumetric, and you dilute it with water until the meniscus just hits that line. So now I know that my volume in my volumetric flask is 250 milliliters. But I also know that I have a certain concentration that my stock solution was made of, and I also know I put 1 milliliter in there. So in order to get the new concentration, the one I'm going to measure the absorbance of, I'm going to take the molarity of my stock solution, multiply it by the volume I put into the volumetric flask, which was 1 milliliter. I'm going to find that's going to be equal to my new molarity times 250. I do this math out and I end up with X being equal to 1.9 e to the minus 7. I'm going to do the same thing with 5 milliliters. Stock solution concentration times 5 is equal to X times 250. I'm going to put 10 milliliters in, and I'm going to put 15 milliliters in. This is how I am going to get the concentration of my 4 different solutions. Confusion? Are we doing okay, guys?
Mm-hmm.
Now I'm going to take those 4 solutions I just made and I'm going to obtain the absorbance of each one of those 4. Then I'm going to plot out the absorbance y-axis versus the concentration x-axis. I'm going to get a straight line. I'm going to determine the slope of that straight line. The slope is my molar absorptivity. Again, note, if you have scientific notation, I would enter it in the box as 0.000 0.000233. Just to be on the safe side. I don't trust Excel that much. All graphs must have that information. All right. Now, remember, I said if I put the Gatorade in straight to my instrument, it's going to top out. So I have to dilute it. Now, when I take my diluted Gatorade sample and put it into the instrument, I will get an absorbance. I'm going to take that absorbance, divide it by the slope, which is the molar absorptivity. I get the concentration of my diluted sample. Now, to go backwards to get the concentration of my original sample. Again, I've got the total volumetric. I've got the total volumetric volume, which is going to be 250 milliliters. I just got the concentration of that diluted sample. So I'm going to take my diluted concentration, multiply it by 250. That's going to be equal to the original concentration times however many milliliters I put of the Gatorade solution into the 250 milliliter flask. In this case, if I put 30 milliliters in, if my concentration of my diluted sample was 5.04 e to the minus 6, I multiply that by 250, divide that by 30, and I end up with my concentration of dye in my Gatorade. Any questions, guys? Okay. Just for kicks and giggles, I'm going to stop share. I'm going to go back to my original. Everybody seeing this slide?
Yes.
Okay, we're going to go and hit the results section. Preview. Start quiz. All right. You're going to look in the student data for student lab data, whatever that's called. You're going to write in what the molarity of your stock solution is. You are going to determine what the molarities of each one of the diluted samples are. And you're going to show me an M1V1 equal M2V2 to show me how you got the concentration of one of those four samples. Questions on this? Question 2, what's the equation of best fit? All you got to do, if you use Excel, is just recopy the equation over. You get 10 points. If you do it by hand, then you got to show me how you did it. If you do it by hand, you cannot use your data points to determine what the slope is. Brian?
Yeah.
That's where you load up the graph, okay?
Okay.
Worth 20 points.
All right.
Do not worry about A. Don't worry about A. All I want is the absorbance of the unknown solution after dilution. Molarity of the diluted sample. Basically, you're just going to take the absorbance of that diluted sample and divide it by your slope. Molarity of your original sample. You're going to take your diluted sample, multiply that by the volume of the diluted sample, and divide by the volume of the Gatorade you put in there. That's it. Questions, guys? I do want to look at one thing before I get out of here. I want to look at the student data. Okay. Okay. This 2.51 there. Do you see that? That is the straight absorbance. Okay? I don't even want to see that. I don't want to see the 2.51 anywhere. That is not useful to you. What is useful is the absorbance of your diluted sample. So you're going to take this, divide that by your slope. That will be your concentration of your diluted sample. Any questions, ladies and gentlemen?
So to go ahead and just delete anything with the unknown solution.
No, this is the only line, Kara,
Okay. I'll
where
go
it
ahead and
says
delete it.
absorbance of stock unknown solution, and it has 2.51. I don't want you to use that line because it's going to confuse you.
All right, I'll go ahead
Okay.
and delete it.
Last thing, post lab.
Where will we upload the graph? In the notebook?
Okay, you guys should have not, you should know how to upload photographs into Excel, into one of these programs. If you didn't know it, guys, you got to figure it out. If you have a Mac, then you are going to have to figure out how to upload a picture in Mac into one of these programs. Okay, post lab. Preview. And my guess is it's only going to be something like, a facsimile of the thing that you just did. First question, read the introduction to this lab. Determine why you're using the maximum value for the absorbance. The wavelength, I'm sorry, let me rephrase that. Determine why you are using the wavelength that has the maximum absorbance of the dye. If your spectrophotometer is constantly reading 10% low, Is that going to affect your result? Think about it carefully, ladies and gentlemen. The answer may not be obvious. Question 3. You've got an absorbance. Don't pay attention to this one. I'm sorry, no, back off. Sorry. This is the equation of your line. The absorbance is equal to 2.00x. Your food dye had an absorbance of 0.65. What is the molarity of your diluted unknown? Okay. Now, you've got the concentration of your Gatorade. Okay? The LD50, by definition, is the lethal dose at which 50% of the population dies. So basically what they do is they keep on upping the dosage that they give to rats until they find out what dose, at what dose do 50% of the rats die. That is given a specific name, and that is the LD50 value. And generally speaking, humans don't want to take anything that has an LD value of 50 on it. All right? So, what you are given is the concentration of your dye in the beverage. Is a very, very low concentration. But you are dealing with 10 fluid ounces of that. So you're going to have to get the amount of moles by taking fluid ounces, converting to liters, and multiplying it by your concentration. You now have moles. Convert it to grams using the molar mass. Then you need to convert it to milligrams by multiplying grams by 1,000 milligrams per gram. Okay. And that's what you're doing for that particular problem. It's nothing more than a dimensional analysis problem. Okay. Now, this next problem. The LD50 is 10,000 milligrams of Allura Red per kilogram of human body weight. Okay? You're assuming that the person has a body weight of 195. So, you need 10,000 milligrams per kilogram. You got to put in enough of that to equal 195 pounds. So you're going to set up a ratio here. 10,000 milligrams over 1 kilogram is equal to how many milligrams over, convert the 195 into kilograms. That will give you the total number of milligrams that will exceed the LD50. You simply then multiply it by 1 glass per 10.2 milligrams, and that will determine how many glasses you have. Last two problems are deliciously evil. Any questions, guys, before I cut you loose? That's all I got for you guys.
Thank you. Have a good night.
You have a good night too.
Thank you.
Take care. Bye, Romero, Brian,
Bye, Professor. Thank you.
Veronica, bye. Veronica, you didn't have any questions tonight.
No, well, my question was the uploading of the graph.
Go
That's gonna-
back. Veronica, go back to the syllabus quiz. All right. There are specific instructions in the syllabus, the safety quiz area.
No, yeah, I know, like how, it's just where,
Where?
like, where are we?
Where are
Like-
you putting it?
Yes,
Okay, there's one question within the results section that tells you to upload a graph.
okay,
That's where you do that.
all right, okay. All right, thank you, Professor. Have
Bye.
again, bye.
Professor,
Tim, Mac, any questions?
I have a comment about the last post lab.
No,
Okay.
thank you.
Okay,
Have a good
Tim,
night.
take care, Mac. Tien,
Yes.
can you hold off for like 5 minutes? I will be right back, honestly, okay?
Yeah, I can do that.
I'm sorry, Tim, but you have a much more relaxed professor, trust me. Okay, so we're looking at the last post of calorimetry. 10? I can't hear you.
Oh, I was muted.
Okay, all right. We're looking
Yeah.
at the calorimetry, correct?
Yes. It's just that I read the remark about in all caps not using scientific notation.
All right,
And
let's just
somehow-
hold on a second. Are you seeing the post lab for spectrophotometric?
Yes.
Okay, so I just need to, I'm gonna keep on reciting what I have here. This is the class 2045. And I'm going into quizzes now. If you're not seeing what I'm describing, let me know. This has new quiz edit categories. So I'm going down and I am finding the post lab for calorimetry, correct?
Yes.
All right, so I'm going to grade it. Do you mind? Okay, let me do one more thing. And that is, okay. I know I just got out of that.